Hi, I'm Seth Johnson with Powerside. Today I'm here to tell you about an innovative solution we put together with our PowerVar filter product line to help solve a power quality issue at one of our industrial customers. I often get asked what Powerside does as a company. From a high level, we manufacture high fidelity power quality analyzers, monitoring equipment, as well as phasor measurement units, which is coupled with our cloud-based CubeScan platform, which is a fleet management software that allows us to do data analytics, allows for real-time monitoring, as well as different reporting functions such as IEEE 519 and various other types of power quality reports. And then on the correction side of the business, we manufacture both low and medium voltage power factor correction and harmonic filtering solutions. Our product ranges typically from 208 volts up to 38 kV class, so it's a very wide range in terms of what we cover. But again, primarily focused on power factor, harmonic filtering, mitigation, and certainly voltage stability as well. So today I'd like to bring to you a specific application which was somewhat unique in nature, which really speaks to the ability that we have as an organization here at Powerside. So this client that ordered this product here does aluminum extrusion. That's their operation. They have 5 services that are coupled to a 13.8 kV distribution line. Each of these services operates a press, and the operation of the press is fairly simple in nature. It takes a large billet of aluminum, it presses it through a die, and extrudes it into, a certain size, shape, dimension, length, etc. And that's operation happens quite frequently throughout the day, over and over and over again. And this facility runs typically 2 to 3 shifts a day, so their load is quite significant and changing quite frequently. This client came to us for a power factor related penalty that they were receiving from their utility power provider. Now, it's very common in North America and really across the world to have a power factor requirement that consumers have to abide by, and if they don't, they get charged extra on their utility bill. This particular client was paying anywhere between $18,000 and $20,000 per month in power factor penalties. And so certainly that caught the eye of their senior management to try to figure out, okay, what can we do to help, cut down the cost of these penalties. One of the unique things about the utility that was serving power to this client is that they have a power factor requirement of 95%. Now, this is certainly on the high side of what we see. 90% is very common. And then, of course, on the other side, we have some clients that are KVA billed. And with KVA billing, you need to maintain a unity power factor or a perfect power factor, or you're paying for that waste. So when this client came to us, we went through and did electricity bill analysis to determine what they needed for correction. But when we got a little bit deeper and peeled the layers back of the onion, we began to figure out that they already had power factor correction equipment scattered throughout the entire facility. However, no one was sure if it was operating, if it had failed, if there was any maintenance done, etc. So we offered to go do a site visit, meet with the customer, and we looked at some of the units on site there. And these units were from all different types of manufacturers, some older, some newer, but all of them had essentially failed in some way, either with blown fuses, capacitor cells that were bulged, or contactors that had also failed or burnt up. So we immediately said, we don't really feel comfortable looking at this project further until we get some more concrete data on what the load profile looks like across this facility. So here at Powerside, we offer a program called the Power Systems Analysis Program. And this is a program where we use this PQ3 device in a portable configuration, and again, this is what we manufacture here at Powerside. And this portable device is coupled with a 4G modem, and so we sent this to the customer site. They installed it on each of the main services going into the facility, and we were able to capture a significant amount of data to better understand, you know, what it was that they were experiencing from a load profile, as well as any other voltage conditions, power factor, harmonics, etc. On the screen here, you'll see an image of what we had captured with that data. Now, what you're seeing on the image is a function from our live meters capability in our CubeScan platform. And you can set these parameters to look at anything, but it's very helpful in understanding what's happening in real time. And so as you can see here, the operation for this pressing cycle happens, you know, roughly every 1 to 2 minutes. You get certainly a peak in current, the voltage drops, you have increase in kVAR, and the power factor, of course, that you need to correct for. So this was very instrumental in helping us understand what the application was and what we were dealing with from a load perspective. Now, keep in mind that what you're seeing on this image is just one of the services. Each of the services had a very similar load profile. Some the pressing cycle was a little bit shorter, some of them was longer, some of it was higher current, but generally speaking, this was basically what we saw at the facility. So when we realized that, you know, a lot of the capacitor banks that they had on site previously had failed, this certainly started to make sense because, you know, we saw contactors that were burnt up, capacitors that had failed, fuses that were blown, etc. And so the dynamic load profile that we were seeing from this customer led us to develop what is somewhat of a unique and custom solution for this customer. And I'll share with you a little bit about it now. So, you know, the traditional way to do automatic power factor correction is to use what we call contactor switches here. So these are contactors, they open and they close based on the control algorithm in the power factor relay. And this works great for loads that do not change extremely frequently and you want to maintain a high power factor. However, when you have loads that cycle fairly quickly, for instance, like we're seeing in this application, or let's say in an application like welding, where you have a very high amount of current for a very short duration, these contactors are not designed to switch on and off that quickly. And there's several reasons for that. The way a contactor operates is it uses the coil to close, and it closes all 3 phases simultaneously. So when this closes, current flows through the reactor down to our capacitor cells, and then when it opens, it gets a signal, it opens, and we have residual current, or I'm sorry, residual voltage in our capacitor cells down below. And per IEEE standards, we need to make sure that voltage discharges below 50 volts within 60 seconds before we can bring that or cycle that stage back on. So you're very limited with contactor switch systems to turn on and off stages rapidly or quickly. Now, one of the things about this particular application is that there was a very high base load that was there. And so this system here is designed, it is 1000 kVAR or 1 megaVAR, depending on your preference. And it's designed with 800 kVAR of contactor switching with the additional of 2 stages that are thyristor switched. And as you saw in that previous image, for the load variability where it increases during the pressing of the billets through the extrusion process, these thyristors can turn on and off in as little as 3 cycles. And the way that it does that is there's a direct connection for B phase all the way through, and then A and C phased are switched at the zero voltage crossing point. It's basically a transient free switch, so we can turn them on and off as quickly as we can, as needed, as the load changes, without having to worry about discharging voltage in the capacitor cells down below. And one of the things this is going to help with is we're going to be able to use the thyristors to do all of the fast switching required during the pressing operation, while we're using our contactor base here to correct for the load that is much more stable and much more predictable. And of course, you may notice here that, you know, this is not just a standard capacitor bank. This is technically what we call an LC filter or a shunt filter. And what that means is we have reactors which are in series with our capacitor cells. And the reason why we do that is because of the proliferation of nonlinear loads in the modern electrical power distribution network. What we're trying to do is prevent these capacitors from amplifying or creating a resonance with the harmonics that exist in the system. Now, luckily for this application, the harmonics weren't extremely high. However, they were enough where we certainly needed to use detuning reactors in this case. So these reactors help prevent these capacitors from being a low impedance source for harmonics, and then they also prevent the capacitors from amplifying harmonic content on the system. And then one of the other things to note about this system is that this is coupled with a main breaker. So this is a 2000 amp ACB breaker, which the client is using what I believe to be known as the tap rule and the NEC code. So they're coming right off of the main bus bar of the switchgear directly into the main breaker, and then our equipment would operate as such. I mentioned earlier about using our power systems analysis program to detect and determine what we needed as a solution here, and this certainly proved to be invaluable for this application and this client. But when we were able to provide that data to the customer, they were so impressed with the ability to look at data in real time and also use our cloud-based monitoring CubeScan software to be able to look at each of the 5 main services they had at the same time, that they asked for us to embed the P-Cube into our correction solution. So here we have a P-Cube which will be looking at and monitoring the main service on all 5 of the main transformers feeding the facility, which then they can look at and get accurate power data, compare it with their utility bills, as well as understand whether or not they're meeting their power factor requirements. One of the things that's really cool about the P-Cube is that it's got different inputs and outputs on it, and this is coupled with a digital input. We call it a wet digital input. And I mentioned earlier about the fact that this client had several capacitor banks that previously failed at their site. They had no idea that they failed. They had no idea when they failed. You know, it just kind of was a slow death of all of the power factor correction that they had in that facility. Well, what we did here is we're using our power factor control relay, and we've set up different alarm conditions. So if there's an event where there's undercompensation or overcompensation or a blown fuse or something that occurs inside this system, we've actually wired this digital input through the alarm contact on our power factor controller. And what this is going to do is it's going to send that signal up to CubeScan, which they'll be using on a regular basis to look at their power quality as well as their general load conditions. And then they'll know, hey, you know, switchboard A, we need to go look at that capacitor bank. There was an alarm that was triggered. It may need to be serviced. There may be a blown fuse or a replacement component that needs to be looked at. And this was really valuable for this client because they don't actually have on site a robust maintenance staff that's very knowledgeable about this type of equipment. And so being able to have this set up for them, and they can get notified as soon as an alarm condition occurs, was extremely valuable. So I wanted to share this with you guys as an example of what we do here at Powerside, and kind of the ethos of our existence. I like to say that one of the great things about what we do is we detect power quality problems and we correct them, and this is a great example of that. Please reach out to us via our website or at sales@powerside.com. And please follow us on LinkedIn, and we look forward to doing more videos in the future. Thanks.